Hello everyone, welcome to this video. My name is Amir Ahari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you how you can have access to the ocean salinity data in the Google Earth Engine platform. So let's go to the code editor environment using JavaScript. First of all, we need to search our desired data or the ocean salinity, and we want to know that what kinds of products available in this regard. Go through the search places and dataset, and then go browse data catalog. Here, through the browsing by tags, you will be able to find your target dataset. For example, we need to search, and also it would be better to search those of keywords that covers a broader topic actually. For example, instead of searching about salinity or sea salinity or something like that, write something about the ocean to see that how many products available for the oceans. As you can see, 23 products available here and various products available here, and you can see them. And one of the famous product is HECOM products, provided water temperature and salinity, and also the sea surface elevation that is very applicable for the open seas. So, and also the other products also available, some of them for surface temperature, some of them for chlorophyll, and some of them only covers the reflectance in the sea surface water, and something else is available here, and you can see. And also it seems that the one product available for the salinity in the time I'm producing this tutorial, that is April 2024. That's so. Then go to the product and check the information. As you can see, this product is available since 1992 with daily temporal resolution. It is daily because I have already checked it. And as it is here available in the bands, the spatial resolution is around 9 kilometers approximately, and provided water temperature and salinity for different depths from the water surface to the subsurface region. But in my experience, would be better to use only the surface data, because when you go to different depths in the processing, you will see not really accurate data, and also you will face with some sort of challenges and errors in the values, and also would be better to only use these products for the surface estimation for now. And also you can use in 2 meter or 4 meter depths if you want. It depends on your application, but I prefer to use only the surface one, because it's including some uncertainties for the subsurface estimations, at least in the projects I have worked. And also I didn't work on the validation or verification of this product ever, and just here I'm here to show you this product is available, and you can use it in your own project for the accuracy assessment, verification, or something like that. It's up to you. You can do in your own projects, because I didn't try for the validation or something like that. So, and now I want to use this product in the Earth Engine. It's very simple. There is no big deal. According to the tutorials I have already published in my YouTube channel, using the same techniques, you can call this product in the code editor environment and use them for extract information or download available information here. So, for example, first of all, when we want to use this product in code editor, we need to copy and paste the name to the search places and datasets available here. You can see then this product showed by the new tab here, and through the import you can import it into your code editor environment. So in the next step you can set your region of the interest, but here in this tutorial I'm gonna show you how we can process the data without defining a region of the interest at first. Although finally at the end we select a specific region for download the data or get the time series or something like that. But here in this step, for now I'm gonna show you, without setting a region of interest, we can do some sort of analysis in the Earth Engine only for coarse spatial resolution data like this. In 10 kilometer or 5 kilometer data, we can do very affordable processing for the coarse spatial resolution data and time series. So just make a new variable, as salinity is the target band, a variable with the same name equals to image collection, and here I'm assigning image collection to the salinity, and then use the filter date. So in the filter date, you can set a period from 1992 to 2023 based on availability information here. For example, I'm gonna use 1 year to show you some example. Only for example 2010. Filter date, a starting date equals to 2000 date with a string format, and the end date should be 2011, 1 year after. And among the all available bands here, we need to select the surface salinity. As you can see, seawater salinity in practical salinity units, PSU, the unit is PSU, at the depth of 0 meter, meaning that it's for surface actually. So the salinity 0 is the target band. Copy and paste it into your code, and then through the print you will see how many images available in this regard. So salinity, let's check the band's name. Yes, salinity. And then you can see 365 images available, meaning that for each day we have 1 image showing the sea surface salinity. In the next step, you want to know that which areas covered by this product. Is it including all, does this product include all the water surfaces, even lakes, or no, only the oceans? So to answer these questions, it's very simple. There is a very simple technique. There are 365 images here, and also maybe it is too much for the visualization. Only we can use calendar. Here we can define a new filter using the calendar range to set a specific mount to call the data. Throw the dot filter earthengine.filter.calendar range, helping us to select a specific mount in which we can call our data. The specific mount is, for example, I want to assess, or I want to see the sea surface salinity for the January for this year. The start mount here, there are some arguments. The start mounts or end mounts, and the field could be anything. For example, what does it mean anything? If you go to the docs in the left panel and type about filter about calendar range, you will see its information, the function information. For example, instead of field, you can use this kind of words: year, month, hour, minute, day of year, day of month, or day of week. Some of the users asking me how we can filter our data for a specific year of, for a specific day of year, or a specific day of month. And also this calendar range, this function or calendar range is very, very helpful and helping you to filter your data specifically for high temporal resolution data with daily temporal resolution or even hourly. You can select your data for a specific date and a specific month or any other time period you need. So here I'm gonna use month here instead of field. Replace field by month, and start month is January, and the end month, if you want to see only the data for the January, you should use same start and date, starting from January ending to January, like this. So now then use the print here, print for salinity, and run the code. As you can see, 31 elements available here, and all of them are for the January. As you can see, the January from the 1st to the end of the January, the data available elements, and under each element there is one band salinity and also all properties included. Specifically system time start that is very important for the time series analysis. Before go through the time series analysis, I want to show you how we can visualize this product, the only images for the January in 2010 using map.center object, helping you to see the salinity bands here. But before showing an image collection, you need to stack all the salinity elements into a single file. So here, make a new variable stack equals to get salinity, as you can see, get salinity, then through those two bands, we can make one image with 31 bands. As you can see here, we have one image collection with 31 elements inside, but here through the stack, as you can see, I print the stack, and here you can see that now we have one image with 31 bands. When you want to have a stack layer for download or visualization, it's very helpful. So, and now through the map.add layer, I can visualize all the bands included in the image or contained or available in the image. So here I'm gonna show a stack layer, and we don't need to clip it based on the region of the interest because I want to see the global coverage for this product. For example, in the United States, there are some water bodies here, I don't know about them, and I want to know that even this product cover this region or no. So, and stack, no need to clip it, and also leave the visualization parameters empty, and then the layer name is the salinity band, and finally use the false to avoid automatic visualization. It's very important. So use the false and run the code to see that which regions covered by this product globally. If you check the salinity on, you will see the global coverage for this product, which areas or which water bodies covering by this product. If you want to see better, turn the map view to the satellite view. For example, Caspian Sea is one of the big inland water bodies. You can see that's not covered by this product, but Persian Gulf or some regions, for example, Mediterranean Sea, I don't know Mediterranean Sea is which one, this region or this region. Sorry for my mistake if I have some mistake. Oh yeah, Mediterranean Sea is here and Black Sea is here. I'm sorry for some mistake I have for the name of some regions. Anyway, where were we? And I was talking about the global coverage. Yes, as you can see, it is coverage. It's covering lower and higher latitude regions very well. And now, through the layer setting, go to the layer setting available here. You can choose any dates you want in the January, and then through the increasing contrast, you will see the salinity value for the region of interest that is global. For example, my region of interest is south of my own country, the Persian Gulf here. And now I'm gonna increase the contrast based on the region I'm displaying here. For example, using this visualization technique, and here you can see the value changes more accurately. For example, the brighter region, higher salinity, and the darker region, lower salinity. But the range of values is not correct. Here, If you go to the data description, you will see in the bands information we have one scale and one offset. A scale and offset meaning that we have a value that should be multiplied to the bands, and we have another value that should be added to the after multiplication. So here, copy and paste the value and make a function here through the dot map. Whenever you want to apply an equation on each available band, on each available element under an image collection, you need to use dot map and then define a function and do calculation or write your equation inside the function body. So each input image consider it as an img and then make a new variable with any names you want equals to get the input image and then multiply to the, so here you can see that multiply to the scale factor dot multiply a scale and then add to the offset value, and the offset value is 20 here and the offset value is 20 and return, and finally the function returning the bands with the input properties, with the properties of input images such as system time start and system time end. Save your code and run it again. And when the code is running, a new Salinity map created. This is the same band, same image, but this time the range of values is corrected. And now I increase the contrast and you can see that now through the inspector you can see the real value for this pixel in different bands. For example, I select this region like this and then throw this item in the, or throw this option in the actually the plot setting. Here we have a new option or new button here. If you go through this, you will have a plot that's showing the value of that pixel in different dates or in different bands available in the layer stack. And then through the download CSV, you will be able to download the CSV format file that's showing the salinity for each date for the selected point. So with the correct range of value. In the next step, I'm gonna show you how you can plot the values of ocean salinity or sea salinity for different regions. Imagine that here I'm gonna select a region or I'm gonna select a point using add marker. For example, here I'm using add marker, this product imported globally, and I want to select a region or a point, a specific point or a specific coordinate in the Persian Gulf. And in the next step, I'm gonna plot the salinity variation for this point for example 10 years. It's very simple. Now I'm making a new variable. This is a new salinity number 2 equals to, again, or you can copy and paste the same variable. The salinity variable could be pasted here, but this time with a new name. For example, salinity number 2, or we can write salinity for Persian Gulf. Yes, like this. Now we have an image collection that's selecting each surface salinity bands from, for example, from 2001 or 2000 to 2011. Without considering calendar range, I want to see the variation of the salinity daily with the daily temporal resolution over these 11 years. So, and the scale and factor remained in the code because we need to see the salinity value changes with the correct range of values. So, in the next step, throw the print, make a new actually chart to do this. User interface chart image.series. As you can see, some arguments available under this function. Instead of image collection, import or input salinity for Persian Gulf, and region is the specific point selected by the marker, and reducer, as I am selecting a point, I need to select or pick the closest value or the first value that is selected by this marker. Accordingly, use the reducer dot first like this, and instead of a scale, set 10,000 because the spatial resolution is 9,000 meter or 9 kilometer. Roughly, I turn to the 10,000. Also, you can use 9,000. There is no clear difference between in the coarse spatial resolution data. And then instead of X property, you need to import the properties including the date acquisition, that is system time start, like this, and run the code. In the right panel, you can see a new chart that is generating. This chart will show the salinity for the selected region from 2000 to 2011. So, because of large number of images, this is daily and more than around 3,500 images calling in this variable, and it is normal that taking a little bit more for the processing, and also be patient when you are working with such kind of data with high temporal resolution. Maybe the water salinity, as you can see, the water salinity values plotted here, but unfortunately, because of an outlier value here, we have no we face with the wrong visualization, and also we can't see the variations easily because of one dropped value that is available here. But for example, if I reduce the temporal scale, for example, temporal extent to 2000, where we can remove this part to see the variations easily and clearly. And there are some methods, statistical techniques, helping us to remove such kind of outliers that is beyond of this tutorial. And maybe in future I produce some tutorials about skipping such kind of values in our analysis. So, because in the remote sensing, we are doing the data analysis, but the kind of data is spatial and satellite based or spaceborne, and you can use all the statistical methods available in the data science for the satellite images. The only thing is different is the nature of data and the format of data. So, and back to descriptions, or back to our code, and now I'm gonna reduce the time extent from 2000 to 2010. Run the code again, and again we need to be patient for a new chart that is under generating. So as you can see, when that outlier value is skipped, you can see that we can see the variation, the water surface salinity in this region. But another question is, maybe you will have some such kind of questions. Maybe you have these questions, how we can compare the salinity of, for example, a point in the Gulf of Oman and a point in the Persian Gulf. It's very, very simple. Make a new geometries, throw the dot add layer, and then go to the edit layer properties and change its characteristic from geometry to a feature collection, and then click on OK and throw the marker again. I'm selecting a point first in the Persian Gulf and then in the Gulf of Oman. So in the next step, now I have a feature collection. As you can see, this is not a feature, a single feature. It is a feature collection including two separate features as geometry number 2. So now we have 2 points. We want to compare their values for the sea surface temperature in Persian Gulf and Gulf of Oman. So this time use the print, but with a different chart image.series by regions, helping us to visualize the two time series for multiple regions. So, or multiple time series for the multiple regions. Again, instead of image collection, we need the same variable, the salinity for Persian Gulf, but this product not limited, not bounded to a specific region. Just I turned its name normally and without any doing spatial filtering technique. So the regions now this time, instead of geometry, we will have geometry number 2, and in each feature or in each location that's selected by green marker, I want to get the first value. Throw the Earth Engine .reducer .first, and then we need to identify for which band we want to visualize these time series for the selected locations. The band name is Salinity 0, like this, and the scale value should be equals to 9,000 or 10,000, no matter. And instead of its properties, input the system time start, because system time start explaining the property is the property that explaining the date acquisition of the satellite or product. So, and the series properties, because some of these products, such as the HICOM, combined from satellite estimations, ground informations, it is not directly estimated only by the satellite. It is such kind of these data are assimilated and combined by satellite in situ models and all together. And the series properties referring to those to that field or that characteristic or that property in our geometry that showing the different object value for the selected points. For example, if you have a shapefile for the 2 point, for example, if you have a shapefile including 2 points, and also each point has a separate object ID, and that object ID helping you to differentiate the results coming from object 1 and the result from object 2. But here, as I'm selected these 2 points inside the Google Earth Engine through the geometry, we can set, for example, system index. System index is useful for all the shapefiles, whether imported from outside of Google Earth Engine or the shapefiles you have created through the drawing tools here. So, and now we are waiting for the second chart, and also it's taking a little more time because larger number of images including for the processing. For example, in the first time, if we had 3,000 images, 3,000 values for the plot, this time it is as you can see, it is more than 5,000 images this time, and also be faced with such kind of error. But we can reduce the time scale from 2000 to, for example, 2005, just for a smaller period. See how the geometry, how the series by region works. A smaller period and also the faster processing speed. And here, if you go to the geometry 2, there are some columns that one of them is system index, that's helping you to differentiate the features from each other. The first feature is feature 0 with a blue color, and the second one is feature 1 with a red color. As you can see, there is a clear difference between the salinity in the Persian Gulf and the Gulf of Oman here, and you can compare multiple regions by this technique, and then also you will be able to download the result using CSV format for the further processing in the Excel or any other softwares you want. And in the final step, I'm gonna show you how you can download the raster images created here. For example, here for the January, we were talking about the January, a specific month in which we wanted to download the all images that is stacked for the January 2010, that is stacked layer. So here, just you can make a export function or export command here, export.image to drive. So the image for export equals to the stack. If you have a region of the interest, for example, you can define a new geometry here, and then, for example, I'm gonna export the Persian Gulf, and here inside the new geometry using a rectangle tool, I'm selecting my region of interest as geometry number 3, and when I'm going to export the result, we can clip it based on the geometry number 3, and then the description referring to the name of output GOT file, that is, for example, Persian Gulf Salinity, as you can see. And after the description, we have a scale. The scale is 9,000 meter because the spatial resolution is, and then the region for the export is geometry number 3, and then the maximum pixels we can have in each separate TIFF file that is downloaded from the Earth Engine must be equals to 1E13. And also, if you have a larger image with more dense pixels, you will have multiple frames for the region of interest. But this problem always occurs only for the high resolution images compared to this product. For example, Landsat with 30 meter or Sentinel with 10 meter. Lots of time we can see that the maximum pixels helping us to compress all the pixels into a single frame and also to avoid from multiple frame exporting. So after this, we need to set the CRS or coordinate system equals to get information from the information available in the stack .crs. Select the coordinate system and attach to the output here. And finally, you can set a folder for the output. For example, I want to save this product in the test folder. So save your code and run it again. So in the task, you will see we have a new layer, that is, we have a new unsubmitted task. Click on run. You can see its information, then click on run, and waiting for the running process to be over. And once the tab color turned from the gray color to the blue, meaning that the result is ready, and you can pick it up from the Google Drive and open it up in your own software in your desktop. So back to the processing steps. Now in the next step, I'm gonna give you an extra topic about conversion of this product. Maybe you want to convert this product from the daily format to for example, the monthly version, because for some of the dates this product is available. For some dates, I think after 2018 or after 2017, the temporal frequency in this product highly increased to a couple of hours, and also with higher temporal frequency. So, and also you will have the sea surface salinity every, for example, 2 hours, 3 hours. I'm not sure exactly. Just I know that the temporal frequency highly increased after 2018, and you can check it by the techniques I mentioned and showed you. But for example, we want to convert them. We want to see the variation in the monthly format, not daily, or not, for example, in couple of hours. That's important thing. If you followed my tutorial, in the previous tutorials in my YouTube channel, I showed you how we can use temporal collection function, helping us to calculate the temporal composite in the Google Earth Engine platform. Although there is not a built-in function in the Google Earth Engine to convert the high temporal resolution data to the, for example, monthly or temporal collections, but Google developers developed this function and distributed on the net for the users. And now I'm using that function and trying to teach you here to enable you to convert the daily or high temporal frequency data to the, for example, monthly or yearly or seasonally or something like that. So just to make a function, write function like this, and then name of function that is temporal collection. I have showed you this function and it's working in most of the tutorials I shared, because this is the one of the most valuable functions we have in the Google Earth Engine that is shared with us, and we can use it to get various products with the various temporal frequencies. So these functions including multiple arguments. One of them is collection of input image, and the next is the start date, and the next is, for example, the next variable could be the count, the number of images we need to have with an interval, the temporal difference, the delta time between first and second image in the time series, and the unit of time also. These are important arguments we want to use to calculate the various temporal collections. So first we need to make a list of sequence. Earth Engine dot list of sequence. I know this part of programming in the Earth Engine is a little hard and difficult, specifically for the beginners. If it is hard, and also if you cannot write this equation or function, I will suggest you to copy and paste it in your own code and use it like this. And if you are Google Earth Engine users, and most of the time you are working with Google Earth Engine, I highly suggest you to learn the temporal function code, because because most of the time you must use it to get various outputs. So, but if it is still make a challenge for you in working with the Earth Engine, my code example is available in the description box below the video in my YouTube channel, and you can pick it from my own code and copy and paste it into your own code and use it for your purpose. It doesn't matter because it is not my function. All of the tutorials and techniques I'm presenting you, their material available on the net, and someday I had to know this kind of information and data, and also I started with the tutorials available on the net freely developed by the Google or the other users, and I learned and I used them in my own project, and now I'm adding something and sharing with you, and I hope you can use it very well. And just I'm gonna show you how the temporal collection works, and also there is no force to learning this function if you are not a permanent user in the Earth engine, I mean. So the list sequence needed a start number or end number, because when you want to make a list, you need to have a start row and end row. The start row, the rows in the list starting from the 0 and ending to the number we have set for the count Earth engine number to have count value as a number, Earth engine number count. But here we need to make a list according to the size of list defined according to the number of images. A number of images, when starting with 0, we need to subtract it from 1. That subtract from 1 like this, and remove this step and count. So in the next, we need to convert the start argument from the string format to the date format. In this function, write origin date equals to Earth engine.date start, because you import the date like this with the string format, but we need to convert it from the string to the date format. Then the function here returning a sequence, a list of output images with image collection format. This is an image collection. Actually, we have a list with image collection format, and now for each row in this list, we need to set a start and end date through a function. The input each row in the function, for example, here we called it as an I, and for each I inside the body for the new function, we need to calculate the start date and end date. The start date equals to, so now from the origin date or start time dot advance, so that advance according to a delta time and unit. The delta time here, as you can see, the delta equals to the interval Earth engine number to convert interval to a number, Earth engine number used, and the interval or the delta time multiplied applied on each row, that is I here, according to the unit we already set. And for unit you can use week, year, days, month, so like this. And then repeat the start date for the end date, this time with minor changes. Instead of start date, this time we have end date from origin date advancing. So here Earth engine number for the delta should be considered 1 unit after the previous unit. After the previous unit that defined the time unit defined in the start date. Accordingly, we need to do some changes. Earth engine number I that add 1 to consider 1 unit after the previous one. So, and now the function finally returning the input collection. For example, the input collection is the salinity data. The salinity data returning for a specific period through the filter date, and according to the start date and end date we defined here. Start date and end date we defined here. And for this period, for example, if we want to get the monthly, the start monthly data, the start date equals to first day of month and end date to the last day of month. During that month, we want to get an average through the dot median, dot mean. And finally, and also you can use the maximum for the period you want to get export, or minimum values, or standard deviation, whatever you want, or median value. For example, I'm gonna get average. So as we want to produce a new time series with ability to do time series analysis in the next step, we need to have properties explaining the date information or acquisition date for each image separately. So here, through the set, I'm making a new properties as system time start, because now we need a new system time start. Although we had system time start in the original collection, but now the temporal frequency changed from daily to, for example, monthly, and for each month we need to have a new system time start. So system time start, and now start date, the start date dot millisecond. Google Earth Engine using the dates information through the millisecond format. And also, if you don't use millisecond, you will face in such time series analysis. And then dot set system time start, again system time end this time, sorry, and this time end date dot millisecond. It's very simple. For the first time, although it's very complicated and tricky, and I understand you, but if you try this code, for example, multiples of time during your project, definitely you will learn it immediately or gradually, and you will be able to improve it in future. When you write some sort of programming techniques in Earth Engine, for example, you will face with a challenge in your project, but because of your information about such functions and such kind of commands in the Earth Engine, you will be able to combine this for making a new function with a new capability to solve your issues without asking questions from someone else on the net or from your colleague. It's very easy to use. So, and then I'm gonna produce a monthly version, for example, from 2000 to 2020 for 21 years, for example, or for 20 years, I want to get the monthly sea surface salinity for the selected region. So make a new variable monthly equals to use the temporal collection. Here we have a temporal collection, and inside the temporal collection we have multiple arguments here. Copy and paste it to know which arguments you will have now. The input collection should be, for example, I'm making a new variable for the salinity number 2. I think we had salinity number 2. No, we didn't. So making a salinity number 2 equals to the same variable, just copy and paste it without and now with a minor change, a salinity number 2 from the input collection, selecting the salinity band for the surface. Filter date, I want to have this data from 2000 to 2020. So, but in my experience, first of all, I prefer to remove the rest of steps, or specifically the part. I prefer to use this code like this. For example, before calculating the real value through the applying scale and factor, just call your data and then set your own filters, and after producing the monthly version, apply the scale factor. This kind of programming helping you to have higher speed of processing in the Earth Engine platform, because the speed of processing is very important. And also, if you do some calculations before using temporal collection, definitely you will face with the user memory limit exceeded problem or heavy processing or something like that. And also you couldn't get the good results in a short time. So now, as you can see, now I'm calling the image collection with the desired target bands for a specific period, and all the rest of processing, specifically for the applying the scale and factor, should be applied after monthly image created. So the Salinity number 2 imported instead of collection. The start date equals to 2000, and the count is the number of output images. We want to have monthly images. As you can see, the monthly images from 2000 to 2020 for 20 years, and each year is including 12 months. For example, this is like that. For example, 20 multiplied to 12. In such equation, we will have 240 months, I think. Let me check in my calculator to avoid any possible errors. 12 multiplied 20, yes. We need to have 240 monthly images. And now the count will be 240 with 1 month interval. And also the unit should be equals to the month, not monthly. The monthly is the name of our variable. So now I'm gonna printing the monthly variable. A new image collection is under computing. You can see that it's very fast and immediately calculated the average of each month. But if you use the map function before the temporal collection, definitely a speed of processing highly decreased. And here we have 240 elements, and as you can see, for each month we have 1 band. It's a good idea. And now copy and paste the map dot function and paste it here to apply a scale and factor after monthly images created. So, and to check the result, to ensure that the processing is done after monthly collection, use the dot rename to convert the name of band to the SSS sea surface salinity. So run the code. 240 elements available. For each date we have sea surface salinity, as you can see. And now, because we have system time start here, we will be able to do time series for the time series analysis for this product. For example, for the geometry number 1 or the first geometry, I need to plot the variation of, for example, the salinity value. So here I'm printing using user interface chart image.series. For the instead of image collection, we will have the monthly image, and the region is, for example, geometry number 1, and reducer is the first Earth Engine that reducer that first, and scale value equals to 10,000, and instead of X property we will have system time start. Run the code again. A new chart is under generating, and you can see that the Persian Gulf saved successfully without any error or challenges. Through the opening drive, you will be able to download the final results. back to the console panel. In the console panel, you will see the monthly values calculated here, and you can see the trend of salinity for this point that is decreasing, and the higher salinities and lower salinities in different dates. So, and you will be able to download it with CSV format. And I hope you like this tutorial as much as I do, and I tried to share you some important things about the Salinity product in the Earth Engine platform, and I hope you can use and learn, you can use it in your own project. If you had any problems, you can reach me out in the comments.